Dear friends, welcome to this channel. In this video, I will explain Central University's Common Entrance Test 2020 Chemistry question paper. In this question paper, we have two sections, two parts, Part A and Part B. In Part A, we have 25 MCQs, which are related to mathematical aptitude, general English, reasoning and analytical skills. In Part B, we have 75 MCQs which are related to chemistry. In this video, I will discuss the first 25 questions in Part B which are related to chemistry. The question number 26, which order of these transition metal complex is correct for delta naught? We know that delta naught is directly proportional to number of ligands. As the number of ligands increases, delta naught increases. And also delta naught is directly proportional to strength of ligands. As the strength of ligands increases, the delta naught increases. In this case, you can find 6 coordinated complexes, and also this one is 5 coordinated complex. This one is 5 coordinated complex, this one is 6 coordinated complex, this one is 6 coordinated complex. This is 5 coordinated complex. If you take coordination number 6, rhodium CN63 minus, rhodium Cl63 minus, Cn minus, the strength of Cn minus is greater than Cl minus. So the delta naught value of rhodium CN63 minus should be greater than rhodium Cl63 minus. Then what is the order? The order will be rhodium CN63 minus greater than rhodium Cl63 minus greater than rhodium NH35 3 plus. So what is the correct option? D is the correct option. The correct name for the complex is given. Here the complex is anion, this one is cation. First you have to write down name of the cation, and after that you have to write down name of the anion. If the anion is complex, then you have to add suffix ate. And also in complex, you have to write the ligands in alphabetical order. This is very important. So in this case, sodium nitritoamine, this is not in alphabetical order, wrong. Sodium amine bromo, not bromo. When halogens are anions, if you take bromine, it will be bromido, chlorine chlorido, fluorine fluorido. Okay, these are the names of ligands. So this one is wrong. Sodium bromido amine, here alphabetical order is missing. In this case, sodium amine bromido chlorido nitrito platinate 1 minus. The oxidation state of platinum is 1 minus. So this one is correct. So what is the correct option? D is the correct option. Which among the following statement is correct? CO is strong field ligand and a good pi acceptor, and so is Cn minus. If you take CO, C triple bond O and C triple bond N minus. Okay, in these two cases, you have pi electrons, pi bonds, so there is a pi star or pi antibonding orbital you have. When ligand has pi star orbitals, there is a accepting of electrons from a metal, so it can act as a pi acceptor. And also it is a sigma donor, COCN minus, both are sigma donors and pi acceptor ligands, and both are very strong field ligands. So what is the correct option? CO is strong field ligand and a good pi acceptor, and so is Cn minus. This is the correct option. A is the correct option. Which of the following ion can be explained by a D2sp3 hybridization and should be diamagnetic? Okay, NaCN for 2 minus, if you take, this is NaCN for 2 minus, in this case the hybridization is dsp2. dsp2 is the hybridization. What is the hybridization? dsp2. And FeCN64 minus, if you take FeCN64 minus, here the hybridization is D2sp3, and F64 minus is outer orbital complex weak field ligand sp3 D2. Okay, in case of D6 electronic configuration, strong field ligand D2sp3 hybridization, weak field ligand sp3 D2, and COCl64 minus, this one also D7 electronic configuration. In this case, there is a sp3 D2 hybridization. So which one is the correct option? B is the correct option. So B is correct. In octahedral complex ions, T2Z orbitals are, we know that in octahedral complex there is a splitting of degenerate orbitals into two set of groups, that is T2Z and EZ. In T2Z we have dxy, dyz, dxz. In these orbitals the lobes are in between xy axis or yz axis or xz axis. So which one is the correct? Triply degenerate set of orbitals, dxy, dyz and dxz. Ez, if you take, Ez is dz square, dx square, y square. Lobes are along the axis, T2Z, dxy, dyz and dzx. Which of the following transition metal ion should have a smallest ionic radius? Suppose if you take radius, this is the radius, and these are the ions. If you take, let us take, this is the radius, these are ions. If you take, for scandium 3 plus, this is scandium 3 plus. From left to right, in periodic table from left to right, there is a decrease in ionic radii. So from scandium 3 plus to titanium 3 plus there is a decrease, and vanadium 3 plus there is a decrease, and chromium 3 plus there is a decrease. After that there is an anomalous behavior, there is an increase in radius, ionic radius. This is scandium 3 plus, this is titanium 3 plus, this one is vanadium 3 plus. Chromium 3 plus, you will get smallest ionic radii, and after that there is an increase, Mn 3 plus and Fe 3 plus. What is the reason? If you take scandium 3 plus, it's a D0 electronic configuration, D1, D2, D3, and after that D4, D5. So if you take T2Z and EZ set of orbitals, let us take, up to D3, the electrons will enter into T2Z orbitals. After filling of T2Z orbitals by single electrons, then there is a filling of EZ orbital. In case of Mn3 plus, in aqueous medium, Mn3 plus, there is an electron in EZ, the outermost electron in EZ level. We know that the orbitals, EZ orbitals, are projecting towards incoming ligands. So there is a repulsion between incoming ligands and these electrons. That's why there is an increase in metal ion radius in case of Mn3 plus, Fe3 plus. When electron enters into EZ, there is a increase in ionic radii. So which one has the smallest ionic radii? Chromium 3 plus has the smallest ionic radii. So answer is A. The correct ground state term for nickel 2 plus is, what is the electronic configuration of nickel 2 plus? Nickel 2 plus is a D8 electronic configuration. So in D8 you can fill the electrons. In this case 2 electrons. First you fill single electrons 1, 2, 3, 4, 5, 6, 7 and 8. This is the D8 electronic configuration. Here you have -2, -1, 0, 1, 2. These are the L values, ML values of dxy, dyz, dz square, dx square, y square and dxz. And what is the total S value? What is the total S value? Here there is a cancellation of spins, plus of minus of cancellation, plus of minus of cancellation. Here you have two unpaired electrons. Okay, each unpaired electron has a plus of spin, so the total spin will be plus of, it will be 1. What is the total angular momentum? It's a sum of ml values. Here what is the sum? -2 into 2, it will be -4. -1 into 2, it will be -2. It will be 0, 1, 2. So here -2 cancel. -4 and +1, it will be -3. You have to take absolute value. So it will be 3 is the ml value, L value. When L is equal to 3, suppose L is equal to 0, 1, 2, 3. When L is equal to 0, S, P, D, F, these are the term symbols. So for L is equal to 3, you have, this is the term symbol L, spin multiplicity 2s plus 1. Here you have to take J value. So what is the L? Here L is equal to 3. What is the symbol for L is equal to 3? It will be F and 2s plus 1 value. S is equal to 1, spin multiplicity 2 into 1 plus 1, it will be 3. So spin multiplicity is 3. And what is the J value? Here the J value ranges from L minus S to L plus S. So what is the L value? 3 and the S value is 1. So L minus S 2 and L plus S is L plus S is 4. So the maximum value is 4, minimum value is 2. It will be 2, 3, 4. More than half field you have to take maximum J value, that is 4. This is the ground state term symbol. So what is the answer? 3F. 3F4. Here 3F is the correct option. A is the correct option. The correct statement about the selection rules in electronic transitions should be electronic transitions. Here what are the transitions? Electronic transitions. We know that for electronic transitions, the spin delta S should be 0. Means the transition should be between the states which are having same spin multiplicity, and the delta L should be plus or minus 1. Here there should be change in symmetry of state, electronic state, when there is a promotion of electron from one state to another state. So delta L plus or minus 1 means there is a change in parity. Parity means it's a symmetry. When there is a change in symmetry, there is a change in parity. So which are allowed? No change in spin multiplicity and there is a change in parity. So electronic transitions involving a change in parity and between the states of same multiplicity are allowed. So first option is correct. So A is the correct option. Which of the following complex is more likely to deviate from spin only magnetic moment? We know that spin only magnetic moment mu s is equal to root over 4s into s plus 1. When L value increases, Thus, there is a deviation of spin only magnetic moment. So, if you take Ni2 plus, it's a D8 electronic configuration, Zn2 plus D10, and Mn2 plus it's a D5, and cobalt 2 plus it's a D7. We know that for completely filled and off filled electronic configurations, L is equal to 0. The total angular momentum L is equal to 0. Here also L is equal to 0. So in these two cases there is a minimum deviation from spin only magnetic moment. Let us compare D8 and D7. Okay, in this there is a splitting of orbitals. T2 is a set of orbitals and E is a set of orbitals. So if you take D8, 1, 2, 3, 4, 5, 6, 7 and 8. This is the D8 electronic configuration. Here we have dxy, dyz, dzx. Let us take -2 and -1, and dz square we know 0, and this one is let us take +1, and this one has +2. Then what is the total L value for D8? What is the L value? Okay, total L value for D8. Here 2 into -2, -4, 2 into -1, -2, and 2 into +1, +2. Here there is a cancellation of -2 and +2. You have -4. -4 plus 0 plus 2. So it will be -2. So L is equal to -2. If you take absolute value, it will be L is equal to 2 for D8 electronic configuration. If you take D7, this is a arrangement of electrons. 1, 2, 3, 4, 5, 6, 7. So this is the arrangement. 2 electrons, here 2 electrons, and here single electron and single electron and single electron. So in this case, -2, and this one is -1, and this one is +1, and this one is 0 and -2. So -2 into 2, -4, -2, -4, -2, and +1, 0 and -2. So what is the value you will get? -2, -2, it will be +2. -2, -2 cancel. So -4 plus 1, it will be -3. So for D7, -3, if you take absolute value, you will get L is equal to 3. What is the L value for D7? L is equal to 3. So when you compare D7 and D8, D7 has high L value when compared with D8. So this complex deviates more. So what is the correct option? D is the correct option. When D value is more, there is a coupling of L and S. You have to consider angular momentum while calculating magnetic moment. So when there is an increase in L value, there is a deviation from spin only magnetic moment. Which of the following molecules is odd one in bonding properties? CO3 2 minus, it's a trigonal planar, we know. SO3, it is also trigonal planar. CH4, it's a tetrahedral. And BF3, it's a trigonal planar. Very simple molecules which are given. So if you take bonding properties, which one is different? CH4 is different. So CH4, it has a tetrahedron geometry. So which one is the correct option? C is the correct option. The main reason for the red color of tris bipyridyl iron 2 should be. So here the ligand has pi electrons. Bipyridyl, if you take, it has pi bonds. When the ligand has pi bonds, it has pi star antibonding orbitals. It accepts electrons from the metal. The excess electrons will be accepted by pi star orbitals. So here there is a transfer of charge from metal to ligand. Okay, this one will be taking place when the ligand has pi electrons, pi orbitals or pi bonds. Then only there is a MLCT transition will be taking place. So in this complex, the red color of tris bipyridyl iron 2 is due to metal to ligand charge transfer transition. LMCT is possible when metal has empty d orbitals, d0 electronic configuration. If you take suppose MnO4 minus, in this case Mn7 plus, in this case Mn7 plus has d0 electronic configuration. In this case there is a transfer of charge from ligand to empty orbital of metal. So the main reason for the red color of tris bipyridyl iron 2 should be metal to ligand charge transfer transition. Which one of the following complexes can be expected to undergo maximum Jahn-Teller distortion? Okay, what is Jahn-Teller distortion? When it happens? The Jahn-Teller distortion happens when the electronic configuration is asymmetric electronic configuration. In asymmetric also, if the electronic configuration at easy level is asymmetric, suppose asymmetric EZ is greater than asymmetric T2Z. First, there should be asymmetric electronic configuration in non-linear molecule. Then there is a Jahn-Teller distortion. If EZ orbital, the electronic configuration in EZ orbital is asymmetric, the Jahn-Teller effect will be more when compared with the asymmetric electronic configuration in T2Z. Suppose if you take CuNH3 H2O2 plus, it's a D9 electronic configuration. So in D9, which one is asymmetric? This is the D9 electronic configuration. So here the 2, 2, 2 and 2 and this is the 1. So here T2 is symmetric electronic configuration, easy asymmetric electronic configuration. In one orbital you have 2 electrons, another orbital you have only 1 electron. So in this case D9 case easy asymmetric. And NiH2O6, let us take 2 plus, it is not given. NiH2O6 2 plus, it's a D8 electronic configuration. In this case D8, let us take D8. One, two, three, 4, 5, 6, 7, 8. Here there is no asymmetric electronic configuration at T2Z and EZ. In this case, there is no Jahn-Teller distortion. MnH2O6 2 plus, it's a D5 electronic configuration. In this case also there is no asymmetric electronic configuration at T2Z and EZ. So this is electronic configuration. So in this case also there is no asymmetric. So here there is no Jahn-Teller distortion. TiH2O6 3 plus, it's a scandium titanium 3 plus, it's a D1. In case of D1, this is the electronic configuration. It's T2Z level, T2Z1, it's a asymmetric electronic configuration. In this case also there is a Jahn-Teller distortion, but in the case of D9, EZ is asymmetric. In the case of D1, T2 is asymmetric. So which one shows more Jahn-Teller effect or Jahn-Teller distortion? The maximum Jahn-Teller distortion will be in the case of D9, that is A. A is the correct option. The most abundant metal ion in a human body is, most abundant metal ion is Ca2 plus, but in this option uh, there is no correct option, there is no option which is correlated with Ca2 plus. The metal ion present in the active site of carbonic anhydride is Zn2 plus. Actually this one is Zn2 plus. The metal ion present in the protein responsible for oxygen transport is Fe, iron 2 plus. And the metal ion present in the active site of vitamin B12 is a cobalt 2 plus. And the metal ion present in the active site of hemocyanin is a Ca2 plus. Here there is no option which is related to Ca2 plus. I think this question is wrong. The concept of exchange energy supports which of the following? Pauli's principle, Zeeman effect, Hund's law, photoelectric effect. Okay, if you take Hund's law, okay, maximum spin multiplicity. This principle supports the concept of exchange energy. Okay, if you take electronic configuration which has maximum spin multiplicity, that state has more exchange energy. That's why that configuration is more stable. So which one is the correct option? C is the correct option. Which compound is most likely to undergo oxidation addition of hydrogen? We know that this one is a very famous reagent, catalyst, Wilkinson catalyst. This catalyst is used for hydrogenation of alkane. It's a heterogeneous catalyst. In this hydrogenation, the first step, there is a addition of hydrogen to this complex. So this one is the correct option. Heterogeneous catalysis, Wilkinson catalyst. The first step, addition of hydrogen. Okay, remaining cases, when compared with this complex, the remaining cases, the reactivity will be less. So which one is the correct option? A is the correct option. The correct rank of bond order for O2 plus, O2 minus, CO and O2 2 minus. We know that from molecular orbital theory, MO theory, suppose if the diatomic molecule has 14 electrons, the bond order will be 3. 13 electrons, the bond order will be 2.5, and 12 electrons, it will be 2.0, and 15 electrons, it will be 2.5, 16 electrons, it will be 2.0, we know. So suppose if you take O2 plus, it's a 15 electron species, O2 minus 17 electron species, it's a 14 electron species, and it is 18 electron species. In 18 electron species, what is the bond order? Bond order is 1, and 14 electron species 3, and 17 it will be 1.5, and 15 it will be 2.5. What is the order? The order will be O2 plus 2.5, 1.5, 3, 1. This is the order. D is the correct option. The theoretical magnetic moment for gadolinium 3 plus and europium 3 plus should be. Okay, in case of gadolinium 3 plus, we have 7 unpaired electrons, F7 electron configuration. If you take a spin only magnetic momentum, it will be root over n into n plus 2. The number of unpaired electrons 7, so it will be root over 7 into 7 plus 2. It will be root 63. 9 into 7, 63. This one is slightly less than 8. So it will be 7.9 like that. So 7.9. Europium 3 plus, even though it has unpaired electrons, the magnetic moment is 0 due to low value of J. It's an exception, europium 3 plus and samarium 2 plus. For these species, the J value is very, very less. That's why the magnetic moment is 0. This one is exception. So what is the answer? Gadolinium 3 plus, it will be around 7.9, and europium 3 plus, it will be 0. So A is the correct option. How many spectral bands are expected in the electronic transition of Ni-En thrice 2 plus? It's a D8 electronic configuration. In D8 electronic configuration, we have 3 transitions. How many transitions we have? 3 transitions. The correct order of trans effect in the following ligands should be. Okay, the trans effect generally CO, Cn minus greater. Next one is CH3 minus, and next one I minus. Next one Br minus, and next one is Cl minus even, and next one is ammonia, and next one OH minus, H2O, F minus, F minus. Okay, this is the order. So which one is the correct? CO, CH3 minus, Br minus, and NH3. This is the correct order. So A is the correct option. Identify the incorrect statement. Okay. CONH363 plus is a kinetically inert because of octahedral geometry, unlikely to go for a 7 coordinate system. This one is correct. Maximum coordination number is 6. So it will not allow 7 coordination straight system. That's why there is no reactivity of cobalt NH363 plus. NiCN42 minus, it's a 4 coordinated complex, is kinetically labile because of square planar geometry, likely to go to higher coordination system. This one is thermodynamically stable, but it is kinetically labile. This one is correct. This CONH363 plus acid hydrolysis is a thermodynamically favorable because of 6 basic ammonia ligands octahedral geometry. Okay, this one also correct. Since the ligands are basic in nature, when in case of H plus, in presence of H plus, there is a protonation at NH3. That's why this one is hydrolysis is thermodynamically favorable. And NiCN42 minus is kinetically inert. This one is wrong. Kinetically labile, but thermodynamically stable. Okay, even though it has strong field ligands, it's kinetically labile. So this one is incorrect. So which one is the correct option? The correct option is D is the correct option. The oxidation potential for cobalt 2 to cobalt 3 process should be highest for which of the following reactions? We know that when the complex oxidation potential is high means OP increases means it readily releases electrons. It can easily releases electrons. So in which case there is a more oxidation potential. When the complex is unstable, it can easily release electrons. So if we take these complexes, in all these complexes, the central metal ion has +2 oxidation state. This one also +2. Suppose if you take strength of these ligands, we know that En has more strength, and next is oxalate, next one is NH3, and next one is H2O. Since H2O is a weak field ligand, the complex is unstable, the crystal field stabilization energy is low, so it can easily release electron. So which one is the correct option? C is the correct option. The inverse spinel among the following should be, which one has inverse spinel? Okay, we have normal spinal structures, normal spinal, and inverse spinal. Inverse spinal. This is a spinal, MgAl2O4, it is called a spinal. The structure is a normal spinal. Mn3O4 also normal spinal. CO3O4 also normal spinal. But if you take NiFe2O4, this one has a inert spinal, inverse spinal. If you take Fe3O4 also, Fe3O4 also has inverse spinal. So which one is the correct option? D has the inverse spinal structure. So D is the correct option. Which statement is correct regarding acid dissociation constant? Okay, this is acid dissociation constant Ka. Okay, this one is directly proportional to concentration of H plus. Okay, as the concentration of H plus increases, means as the acidic strength increases, Ka increases. We know that pKa is a minus log Ka. So when Ka increases, pKa obviously decreases. Less pKa, more acidic strength. So higher pKa value represents a stronger acid. This one is correct. Lower pKa value represents a strong acid. Higher pKa means weak acid, less H plus concentration. Higher pKa value represents a strong acid. This one is wrong. Lower pKa value represents a strong acid. Okay, here as Ka increases, pKa decreases and acidity increases. So as pKa decreases, acidity increases, or Ka increases, acidity increases. So lower pKa value represents a strong acid. All acids can have same pKa. This one is incorrect. And pKa values does not represent either strong or weak nature of an acid. This one is incorrect. So which one is the correct? Lower pKa value represents a stronger acid. Peroxy linkage is present in which of the following acid? Okay, H2S2O7, this is the structure of H2S2O7. That's double bond OH, and this is the structure H2S2O7. In this structure there is no peroxy linkage. Peroxy means O bond. There is no peroxy linkage. H2SO5, this one has peroxy linkage. OH and double bond O and this one. This one has peroxy linkage. So B is the correct option. H2SO4, here also there is no peroxy linkage. H2SO3, no peroxy linkage. What is the correct option? B is the correct option. In which of the following compounds the metal is in lowest oxidation state? Let us calculate oxidation state. In this case, what is the oxidation state? SO4 2 minus, it's a 2 plus, complex is 2 plus, and bromine, so obviously it will be 3 plus 3, and this one is complex is 3 plus and CN6 minus, so complex is 3 minus, this one is 2 plus. Okay, Fe2 plus, complex is 3 minus, so Fe3 plus, this central atom will be 3 plus. So in this case metal has plus 3 oxidation state, here plus 3 oxidation state, and in this case plus 2 oxidation state. Here metal carbonyls, we know that neutral ligands, the oxidation state of manganese will be 0. So which one has the lowest oxidation state? Mn2CO10. The manganese has lowest oxidation state. C is the correct option. Thank you. In coming videos, I will explain the remaining 50 questions in CUCET 2020 chemistry paper. Thank you.